Pythagoras amongst other groups of opposites gives the square and the oblong, the union of which he asserts produces harmony. How can this be explained? R S Mead's response to this question published in the Vahan in 1898. The 10 pairs of opposites which the Pythagoreans termed the elements of the universe are I, limited and unlimited, 2, odd and even, 3, one and multitude, 4, right and left, 5, male and female, 6, stationary and moved, 7, straight and curved, 8, light and darkness, 9, good and bad, 10, square and oblong. The first of each pair was looked upon as a good element, the second as bad in the sense of negative. Moreover, the terms of the first column seem to be taken as synonymous, and so apparently are the elements of the second column. Perhaps the statement of the questioner means simply that any pair of opposites produces equilibrium and so harmony. Again, if you take a unit square or mode and to it add 3 others, the 3 forming a gnomon, the whole figure of 4 will produce a new square, and the harmony will be restored, but the simplest oblong consists of 2 unit squares in juxtaposition. The union of the square and oblong, the gnomon, may thus be said to produce harmony. But I am not certain that this is the correct explanation of the problem, nor am I even sure that the statement in the question is correct. I would strongly urge students to send in references to all such queries. There may, however, be other explanations. For instance, the Pythagoreans called such a sequence of numbers as 4, 9, 16, 25, squares, and represented them diagrammatically by so many points or modes. Equally so they called the sequence 3, 6, 10, 15 triangles, representing them by diagrams of 3 points or modes, 5 points, etc., arranged in triangular figures. Perhaps they may also have had an oblong series, and a harmonical progression may have resulted from the square and oblong series, but this is a pure speculation, and I cannot see at present how it could have been possible. Again, in Mason's article on Pythagoria in the Dictionary of Greek and Roman Biography we read, as in the octave and its different harmonical relations the Pythagoreans found the ground of connection between the opposed primary elements and the mutual relation of existing things, so in the properties of particular numbers and their relation to the Principia did they attempt to find the explanation of the particular properties of different things, and therefore addressed themselves to the investigation of the properties of numbers, dividing them into various species. Thus they had 3 kinds of even, according as the number was a power of 2, or a multiple of 2, or of some power of 2, not itself a power of 2, or the even of an odd and an even number. In like manner they had 3 kinds of odd. Now a square is an even number, and the simplest oblong is formed by the juxtaposition of 2 mode squares, the sum of square and oblong thus making 3, the first odd number, for 1 is both odd and even, which number was spoken of as defining or limiting the universe and all things, having end, middle and beginning, and so being the number of the whole. Perhaps the explanation may lie in this direction. These suggestions are put forward with all hesitation, and I can only repeat that it would have been better to give the reference to the author who makes the statement. And by author I mean the classical author and not the speculations or inferences of the moderns.